Now we are going to use the double angle identities to rewrite each of these expressions as an expression with a single trig function or as a single number. So let's look at example A. We have 2 times sine of 7 pi over 12 times cosine of 7 pi over 12. These angles are the same, so we can write this expression as sine of some angle times cosine of some angle. We'll call that angle A. This is the double angle identity for sine. So this is equivalent to sine of 2 times A, or that double angle. So in this expression, A would be 7 pi over 12. So we can rewrite this as sine of 2 times A. So that's 2 times angle A, which is 7 pi over 12. Now we want to simplify. That sine of 2 times 7 pi over 12, we notice that we can cancel common factors. We can think about this as 2 over 1. So 2 and 12 simplify to give us 7 pi over 6. 7 pi over 6, that's the pi over 6 family, and that is from quadrant 3. Sine of 7 pi over 6 is minus 1/2. For part B, this is also one of our double angle identity forms. So let's write that out. That's 1 minus 2 times sine squared of some angle A. And this is the double angle identity, or one of the double angle identity forms for the double angle for cosine. So our angle A in this expression lines up with 15 degrees. So this would be equivalent to cosine of twice that angle A. So cosine 2 times 15 degrees. And we simplify. That would be cosine 2 times 15 is 30 degrees. And cosine of 30 degrees, we know that measure without a calculator, that would be the square root of 3 over 2. For part C, we see that we have sine squared of some angle minus cosine squared of that same angle. So we're going to call this angle A. We see that this looks very similar to our double angle for cosine. However, there's one big difference, and we have to be really careful about this one. The double angle for cosine has the cosine positive and the sine negative. And in our expression that we are given to find an equivalent form of this, the signs are exactly opposite of what we would need. So in order to make both sides equivalent, we would have to multiply both sides by minus 1. Then we could get the negative cosine squared A plus sine squared A, and that would be equivalent to minus cosine of twice that angle. So in order to make this work, this is actually equivalent to negative cosine of twice the angle A. So we're going to do 2 times 2 pi over 5. And we have to make sure we have the negative out front. So this is equivalent to negative cosine of 4 pi over 5. For part D, we have 2 times cosine squared of the angle 67.5 degrees minus 1. We see that this fits the form of our double angle identity. So instead of writing the angle, I'm going to put A, and we can see that this is the cosine identity for a double angle. So we can say that this expression is equal to cosine of twice some angle, and the angle that's being used in the expression is 67.5 degrees. So we're going to put 67.5. We're going to multiply that by 2. We get cosine of 135 degrees. And since this is an angle that we are familiar with, we're going to actually evaluate that. Cosine of 135 degrees is minus square root of 2 over 2. That's our 45-degree reference angle family and lives in quadrant 2. So cosine would be negative square root of 2 over 2. Part E, we have tangent of 51 degrees divided by 1 minus tangent squared of 51 degrees. This is very close to our double angle identity for tangent. However, it's not quite the same. The double angle identity for tangent is 2 times tangent of some angle divided by 1 minus tangent squared of that same angle. Do we notice the difference or what's missing from the expression that we are given? And that is this expression here is multiplied by 2, so it's 2 times tangent A, and here we are missing a 2. So these are not the same, so this would not be a direct equivalent to the double angle identity for tangent. So I could not say that this is equal to tangent of 2A, because it is missing the 2. However, we're going to be a little bit sneaky about this, and we are going to make it work for us. Here's what we're going to do. The 2 that was missing, we are going to multiply it in. So we're going to go ahead and just multiply in that 2. However, I can't just come in and change an expression by just coming in and multiplying by 2 whenever I feel like it. So we're going to multiply by 2, but at the same time we're going to multiply by a half. Now what is 1/2 multiplied times 2? Well, these would end up canceling out and we would end up with the original expression. So we're going to be a little bit sneaky here. We're going to put in the 2 that we were missing to have that complete double angle identity for tangent. But if we put in a 2, then we need to counteract that on the outside by multiplying by 1/2. So this is actually equivalent to 1/2, and now what's in the brackets is the double angle identity for tangent. Alright, so let's simplify. The angle A in our expression is 51 degrees. And now we can say these are equivalent, so we'll get rid of that inequality. So we'll have 1/2 tangent of twice the angle, and the angle that we're using for A is 51 degrees. Now we're going to simplify inside of tangent. So that would be 1/2 times tangent, 2 times 51 is 102. This, once again, is an unfamiliar angle. We do not know what the tangent of 102 degrees is. So we're going to leave that just as is. So the expression that we started with is actually equivalent to not exactly the double angle identity for tangent, but if we multiply by 1/2, then we can use the double angle identity for tangent to actually simplify the given expression.